Welcome to our PNBend presentation. Today I will show you the current status of our bending simulation. In this version, we have made a lot of changes to our automatic tool calculation. This means that the tool calculation is now much faster and also much more intelligent. We also made changes to the user interface of the software, and also to manual functions such as tool changes and stop changes. We start by importing a 3D part. First of all, we will take this component. Here we already have a new feature. This means we can now load several parts here. In other words, I now have this part open here, and if I simply load another one here, you can see at the top that this part is opened in another tab, and you can simply switch between these parts with just one click and then work simultaneously on different parts at the same time without any compromises. Once the component has been loaded, the next step is to select the bending machine. We support a lot of different bending machines and their manufacturers such as Trumpf, Modular, EHT, and many more. Now that we have selected our bending machine, the next step is automatic calculation, and here you can see huge improvements. The speed of this calculation has been significantly improved. This means the calculation is completed after a few seconds, and I get a collision-free bending program, which I can simulate directly afterwards. I can stop the simulation at any point and can then take a closer look at what is happening at this point. If I don't want to change anything else in the program, I can send it to the machine and bend it directly. And in this update, we have placed a lot of emphasis on significantly improving and simplifying the manual functions. If we want to change tools, we can do this in the 3D area. We can simply click on our tool and can then, directly in the 3D area, move the tools we need to proceed the process. Another innovation is that we can also add denominations in the 3D tool as well. We can also change the tool length directly by simply dragging over. Another tool innovation we want to talk about is that we can now save our newly created tool setup and load it again. This means that if you use a tool setup for different components, you do not have to recreate it over and over again, but you can create it once and simply load it again for the next component. This step is very simple. You just set up the tool setup once and can then simply save the whole project here. After that, you give the project a name, and when you are at another component, you don't calculate the tools automatically. Instead, you simply select your bending machine, go directly to the tool menu, and can then simply load the tool setup, and we automatically place the tools here and also try to automatically align the component directly on the other component. After that step, it is still possible to move the 3D component again and align it with the tools exactly as you need it for maximum efficiency. In addition to the function for saving tool setups, we have a new function that allows you to generate multiple setups. This is particularly interesting if you have components where you need more tools than you can get on your machine in one program. We can now see at the top left of our information list the clamping area, and you will notice that for this component every bend is bent on the same clamping. But now we have the option of simply saying which of all these bends are to be bent on a separate clamping. I select my respective bends, and tell the software I want all 4 bends to be bent on the same clamping. And then I have the option of generating a new clamping in the extended area. And if I now click on the plus here, only one clamping is generated for these 4 bends. And I can do the same for the other bends. I generate a new clamping and tell the software I want to bend all remaining bends on the second clamping, which adds to the flexibility. Now this results in having 2 different tool setups here. If we now simulate this here, then we can also see how the clamping changes. If we send the program to the machine like this, two NC programs are automatically generated and then sent to the machine. This means that if you have more complex components, you can use this function to extremely easy program. And you always have an overview of which clamping the respective bend is currently being bent on. Another highlight is the automatic calculation of tool adapters. We have a component which leads to a collision. This means that the component would collide with the upper beam of the machine. To avoid this collision, an adapter must be installed. Previously, such an adapter had to be installed manually, but with this version it is now possible for the calculation to automatically recognize that a collision would occur, and that an adapter will be implemented to avoid the collision. This means that we simply load our component, select our machine, and simply do our automatic calculation, and everything else is determined fully automatically. Now the calculation is complete. In other words, we can now see that tool adapters have been automatically installed here, and if we simulate this in our software, we can clearly see here at this point that without having installed any adapters, we would collide with the upper beam of the machine. I can now simply click on the adapters here and can still change them. This means that I can still remove adapter pieces here. I can also move these adapters if needed. And, for example, add other adapter pieces here if they are available on my respective machine. The next innovation is folding. We now fully support folding in this version. In that case, I have a simple fold part here. And once again, we can just simply click on our automatic calculation. And we then recognize, of course fully automatically, that there is a fold in this component, and which tools we need to use for it. Now that the calculation is complete, we can see how the die is automatically placed with the corresponding rebate strip. If we simulate this once, we can see how the component is pre-bent in this program. After that, we move the y-axis and perform the folding. The good thing about this is that these edge strips are modular components. This means that I can simply remove them from here and just as easily reattach them, and you can add any number of these additional parts as you wish, then select them here and attach them to your die. On the one hand, this can happen automatically, but also, as you can see here, completely manually. One more highlight is the ability to use Trump ACB measuring tools. In the new version of our software, these tools are now able to fully simulate the process here. Now you can see the complete tactile discs here, and even during the bending process, we can observe what happens to these contact discs. This means that even if a collision occurs, for example, with these sensing discs, or if these sensing discs cannot be used because there are holes in this area, or other cutouts in the component, then this is automatically recognized and these ACB measuring tools are not used. The calculation tool can then automatically recognize whether such a measuring tool may be used or not and can then be automatically activated or deactivated. In our information list above, we also have the smart option of activating the ACB tools feature. So we can see for every bend, whether an ACB tool is being used and whether it is currently activated or deactivated. Also, we can then simply with a single click at the top of the ribbon, activate or deactivate the ACB tools. Last but not least, we talk about step bending. I now have a component with a very large radius. And in this version our bending software can recognize this automatically, and can then divide this large radius into many small steps in order to create a bending program. In other words, I change my bending area here and can already see at this point all of the individual bending steps. For that I simply select my machine, then do the tool calculation here and then have the option of bending such components afterwards. We then transfer the component to our 2D PN4000 software, to then have our 2D programming and the nesting being generated.